Good morning, pilot teachers and students, and good morning, class. Okay, you may sit down. All right, our topic will be on energy and circular motion. All right, if you can remember, probably you may have seen something, or let's say a plane which may be doing loop the loop, especially in televisions or TV, or sometimes you may have seen people going, especially when they're sitting on a machine and then moving in a fun park. Okay, we are trying to find a motion of anything that is moving around in circle. Okay, not necessarily in a circle, but it is the circle in, or let's say the circle at two different points. One is the top and the bottom. For example, if you have to swing something, there is a highest level in which they do a cross, or in other words, the circle will have to move. So looking at that energy and circular motion, you find that these objects, when they are moving in a circular path, all right, they will have a vertical, or let's say in a vertical circular path, they have a uniform velocity. Right, these objects have a maximum velocity at the lowest position and minimum velocity at the highest position. All right, if you can look at this diagram here. Let's say, for example, this is a circle, and at the top of this, let's say there is an object up here, and it's going to move that way around. Right at this point, you will find that the kinetic energy will be minimum, and then at this point we will have this, which will be maximum, because at this point it is almost like in that object at rest. So when you are trying to calculate the velocity, that is what it simply says. Velocity at this point, the highest point would be minimum, and when it is down here, it will be maximum. Okay. All right, so I want you to just take the notes down quickly. Part of the diagram will be given to you. Got a rope, something like that. Any one of you have a rope? You don't have a rope. Any rope? No. Okay, any one of you have a rope? A string or something like that? You don't have it. Do you have a string or something like that? No. Can you find any? Finish. All right, quickly copy this. That is quite similar to the lessons that we covered. The energy does not changes, or it does not change, and in this case you will have the velocity which will be changing at different position. The highest position of the loop you will have the velocity which is minimum, and at the lowest point will be maximum. Finish. Right, for this piece of information, you find that the loss in kinetic energy at the top or at the bottom of the loop will be always equal to the loss in PE. Or in other words, if one of these kinetic energy is lost, it would change or convert to potential energy. And similarly, that potential energy would be lost to kinetic energy. All right, after you copy this information and notes, I will now give you a diagram, and out of the diagram there will be only one question in relation to motion following a circular path. All right, here is just the information on how we can calculate the velocity at two different points. The height of that would be this. If you will be calculating the height, or let's say the potential energy, then you were given this equation as mgh. But this time it is a mess up here, and the height will be the radius of the circle, because it is making a loop, and therefore this radius and that radius will give you the height. Okay, in case you are not familiar with the equation, that is half mv square minus, or half mv square maximum minus half mv square minimum. Should be half mv squared. Yeah. Should be half mv squared for that minimum. Okay, you only find that is half v squared. Should be half mv squared. Okay, repeat. If you have made a mistake with, okay, this one should be half mv squared. Okay, moving on. Okay, let me explain to you this one more. Because it is almost up here, would be the object almost coming to a rest. Okay, if you are spinning that around, and probably up here, the velocity will be minimum, but it is still going around in a circle. Okay, we cannot simply say that it has stopped and velocity is 0. It is minimum or just less. After this, it may lose most of the, let's say at this point, the potential energy will be almost high. And half of that will be kinetic energy. It will still have some kind of kinetic energy at this point, but it is less than this. And that is why we say that velocity will be minimum. And then you have velocity, which is maximum down here. If you want to calculate the energy of that object that is moving around in circle, then you can use PE equals to mgh at this point. Why? Because you can use this as the radius, and that will give you the height. So 2r equals the diameter of this circle, and therefore it is the height at which this object is taken up, and that is the lowest level. You finish sketching the diagram? All right, this is your activity question. I'd like you to copy the question, and that is the only question that I will give you some time to work through. And when you come up with your answers to that question, we can go through together and then have a look at the answers. Okay, anyway, just a small diagram to show you. For example, this is a loop that it is making. All right, that is the highest point, and then that is the lowest point. Now the question is asking you to calculate the velocity at the top of its loop. Okay, when it is moving around in that some kind of loop or acrobatic move, it is somewhere down here, and then it is making the same loop, but it is asking you to calculate the velocity at this point. Okay, so that is the minimum velocity. The equation has been given to you. Using that equation that was given to you earlier, you can solve to come up with the velocity. Whose pen is this? Is it yours? Can I use your red pen? Here we come up with the answer. Let me see how you... If you need help, raise your hands. use this formula, then because you have this one k loss in this one will be the k. So when you use it, not much of that will be used. Okay, you see half mv square maximum minus half mv square minimum equals to v square. So when you get this one, it will be equals to mgh, because the loss in this would be equal to mgh. So we are trying to find the maximum, so you have to make this v. So you have half v square equals to mgh. Mgh, this h should be 2r, so 2 mg 2r, then plus, because it is minus here, it is plus half mv square. This time you are trying to find the maximum velocity, so mv square, 2 over here will be, when you bring 2 over here, it will be 4r, so you write simply as 4m g, yeah, 4mgr plus 1 over 2 times m given there, the mass, mass will be there, but this time you see you are left with this one, so mass divided by mass, then divided by mass on this side, then you divide by mass again, you see, cancel this, so it will be v square equals to 4 mgr plus 100, because that is the 80 square, and that will give you the, okay, you square root that, and then that will give you the velocity at that point. Let me see your answer. No. Not really. Okay, you are correct, but when you see then, it is not 63. This one will be 2gh. You see the equation given there. All right, I will give you one clue to solve that question. All right, the loss in this kinetic energy will be equal to the gain in potential energy. So what is it? Okay, mgh. All right, since there is a circle, we'll have m, g. What is the height? Height of the circle. All right, it is 200. Okay, the radius is 100. So we have 2r. So in here it'll be half v square maximum minus half m v square, which is equal to mass times, okay, what is this? The acceleration due to gravity. So you have 10 times 2 times 100. We are trying to solve the velocity. Okay, that is the velocity that we are trying to solve. So in this case, it will be half m v square maximum equals to, okay, 4 times m times 10 times okay, should be all right. If we can start off, okay, then it be mg 2r. Okay. Since you bring 2 over here, it will be 4m gr because of that 2. And this one will be plus half m v square minimum. Okay, I'll just leave it here and then you solve the rest. Yeah? What did we get for? Your question is what did we get for? Said? One, because it is 2r, and when you bring 4 over 2 from that side, because of that, you are trying to solve v, you get 4. Is it mass is still there, but you will have to cancel it somehow, and then you, yeah? Okay, look, listen. Looks like I'm going to solve the whole question for you now. Okay. Our marker is also running out. All right, equals to m g 2r because of the height, which is diameter. And then maximum. All right, what is the question asking us to find? At what point? Top of the loop. Okay, so all right, you are, because at the top of the loop, this will be the velocity that you'll be asking to find because it is minimum. So in this case, it will be all right, which one will we bring? This or that on this side? This one? It'll be maximum. But then we have this one as minus half. Are we going to bring this one to this on that side? Okay. If we have to bring this one over here, then it will be plus half m v square minimum. And that is when we have this one as half m v square maximum, which is equals to okay, mg2r. And then in order for us to find this velocity, I will now bring this one to this side. Yeah? Okay. m v square minimum equals to half m v square max minus, okay, mg 2r. Now if you were to find this, it will be, okay, m v square minimum equals to, right, we bring this one over here, it will cancel, that is mv square max, and then be 4 k4 m g r. All right, this time you are now equals to, okay, you cancel this, and then v square equals to v square minus 4 gr. Okay, that is how you can get the, okay, so this mass should be cancelled out because of this. So you have v square equals to v square minus all right, so that is how you can, you just put in those values, and then I'll give you one more example to solve. Okay, quickly fill in the, using that equation. I've almost done most of the work, so just get in those formulas and then you give me the answer, and then I'll give you one example again to solve. Where is a mass given?
No, mass is not given, so we cannot find out. There's two unknowns now, plus the mass. And velocity at the same time.
Okay, velocity given there is 80, that is at the lowest point.
There is no mass to calculate the velocity. So that means there are two unknowns, velocity. If there was mass, then we would calculate.
And the mass, and
But there is no mass. If the mass was given, then you're right, we just calculate it. But unfortunately, there is no mass, so it's a little bit difficult to calculate the situation.
what is the velocity at the top? The loop traveling at 80 meters in a circle of
Some kilograms there.
7. Okay, that is correct. All right, for just placing in those figures into that equation, v equals to v square maximum minus 4gr, and then you get your answer as, all right, what is the velocity? 80 square minus 4 times 10 times, this one will be 100, and then if that is 80 square, it will be 64, 6,400, and then you have this 4,000. So that will be 2,400, and when you square that, the answer will be 49 meters per second. All right, so 49 meters per second is the answer to. Now let's say if you were asked to find the velocity at the minimum, okay, that is what you were asked to find. If you were asked to find this, all right, okay, you can use equals to minimum. So likewise, the same thing. You have this one as v squared equals to 4m okay. And then you can find the velocity at the maximum position. Okay. So looking at our topic again, the answer to the last word problem will be 49 meters per second. And you will solve by going through that, following that procedure to come up with your answers to either the velocity or even if it is the kinetic energy at different points on a circle or a loop. All right, so in our next lesson, we will study something on projectile motion and also incline and smooth incline and also the rough inclined planes. All right, so that brings us to the end of the lesson, and our key phrase will be energy and circular motion. Good afternoon, pilot teachers and students, and good afternoon, class. Okay, you may sit down.